Good morning, good afternoon, and good evening. Welcome to this edition of Open Mic being conducted by ESS Technical Support out of Pune. My name is Narendra Mesrikar and I'll be your facilitator today. All the lines have been muted for now. I'll be opening this up towards the end of the session for question and answers. If you have questions till that time, please feel free to ask them in web conference chat. Today we will be presenting the second part of two-part series on IBM Notes Traveler Administration and Log Troubleshooting Tips. The first part of the was delivered in September of this year, and I sent the link for it in the meeting invite that I sent. So for today's presentation, we have three attendees: Jayesh Parmar, Shrikant Ahire, and Manisha. And we also have our technical experts Raj, Rajit Rai, and Hansraj Mali who will be available to answer any questions. So over to you, Jayesh.
Thanks, Narendra. Hello everyone, I am Jayesh Parmar, Software Product Support Engineer. Manish Jha, Shrikant Ahire and myself are going to present. Here is a list of the agenda items regarding Notes Traveler Administration and Log Troubleshooting Tips, part 2, which we are going to cover in today's session. This open mic is in continuation to our earlier open mic dated 21st September. We will understand further on reading the Traveler server logs with some sample scenarios at a basic level analysis and to understand and resolve issue. So most of the logging analysis and diagnosis at the initial level troubleshooting was covered in the first part of the session. So in this part we will discuss further on log reading and also share information on using iOS 9 with Traveler and what all changes are required on the Traveler to support iOS 9 devices. So as you can see the agenda items, that is understanding Traveler activity, error and usage logs, demonstration on log analysis to resolve Traveler issues, information on system requirements for iOS 9, followed by required SSL settings for Traveler to service iOS 9 devices. There will be a reflector section and followed by Q&A session. Moving to the next slide. Basically in the Traveler synchronization, the device sync and the prime sync are involved. So as we discussed in the earlier session about the prime sync and device sync, so I just some more thoughts on it, like what exactly the device sync and prime sync is. So the device sync is the connection between the mobile device and the Traveler device. That is, the device initiates a connection with the Traveler to email, and that is called device sync. In the device synchronization, the task involved is HTTP. On the other side, the prime synchronization, that is the connection between the Traveler and the mail server. So if there are any updates on the mail file that needs to be pushed to the device, the Traveler server initiates a connection to the user mail server and fetch email. So this is called prime synchronization, that in short we can say prime sync. The prime synchronization is not dependent on the carrier network or the device speed. The task involved in the prime sync is the Traveler task. So the short form for device sync and prime sync is DS and PS, which is mentioned on the screen. So moving on to the next slide. The user synchronize the device with the Lotus Notes server to update their mail, context, calendar information. This activity is logged in the NTS usage log. So the file NTS usage contains information of NTS audit plus the entry for each transaction that system performs on behalf of the devices. So these all transactions which are happening on the devices and the server are logged once they complete. So it may happen that we may think that okay, the transaction is happening and we will check the log. We will not get the information in that information in the log. So once the transaction is complete, that information is logged into this particular usage log. The administrator can monitor the log for any issues such as when the device was last connected, like what was synchronized between the device, if there are any written codes, if successful or not, and the time the synchronizing to complete. So this all information can be useful to the administrator to determine if devices are synchronizing with the server and how long the process is taking to synchronize the data. So on the screen you can see there is a sample transaction. Okay, we'll go more like in detail for this sample transaction. Like we'll learn more on this for each and every line what exactly the sample transaction means. Move on to the next slide, please. So as mentioned, the NTS usage logs all the usages of the Traveler server. So like I will go in brief for the sample transaction shown on the earlier screen. Like in this transaction you can see like the timestamp of the transaction. You can see the device IP address with the server IP address, and there is a user ID, a user identification, what the HTTP server normalized the username to. So it may not necessarily what the user entered into the device, it will be the user's the canonical name here. And there is a URL of the database, that is a mail file that is being synced with the device and the server. So this HTTP:// the IP address and the mail file path of the user will also be seen in the transactions. Move on to the next slide, please. So the sync origin, like the other one is the sync origin. The sync origin is the thing like it will identify who requested the sync. So you can see here a short form as DP or short name as DP. So there are 4 types of the sync origin which you can see here. So one is the PS, that is the prime sync, DM, that is the device manual, DP, that is device push, and SP, that is server push. So this PS, that is a prime sync, which we talked earlier, like the server will initiate a connection with the Traveler server will initiate a connection with the mail server, and device manual, DM is a device manual. This is a manual synchronization initiated by the user to synchronize the device to the server. There is a device push, DP. This was the push done from device to the server. For example, the mail being sent from the device, or any calendar update happened on the device, or if any contact is changed on the device. So the device decided to push this to the server without the user selecting the synchronization option in the UI. So there is one more SP, that is server push. This is the push initiated by the server to the device, such as a new mail that has arrived on the mail server, or any calendar update happening on the server, any contact change on the server. So that will be initiated by the server to the device, that is server push. So there is a followed by the next section is regarding the status written code on request. So the status code next to the synchronization origin field is the code which indicates the status of ended sync. So for example, 200 is success, 408 is the request timeout, and 409 is the sync was cancelled because a new synchronization request came in while old was running, and 500 is the server error, and 503 is the server too busy error. So you will see the status code if anything is going wrong with the transaction. You will also see the status code from where you can analyze or you can understand what has gone wrong. So after the status written code, there is a time. It is a duration, that is number of milliseconds that action took to complete, and there is a user agent section where it shows the HTTP user agent header reported by the device. For a prime sync, there is no real device, so it is logged as a prime sync for the user agent. Move on to the next slide, please. So similarly, if we go ahead in this sample transaction, we see a device ID. So that is device identification. So any changes made in the device, there will be device to server, that is D2S, and changes done on the server, it will be server to device. So I repeat here, whenever there is a changes, it will be either from the device to server or from server to device. So if we talk in a short form, like it will show as D2S and S2D. So that is the changes which will be happening from device to server and server to device. So in the device ID section, you can see the device ID, and there are the column or the section changes from device to server and changes from server to device. There are 18 numbers are there, 0 and 1 numbers are there. So what exactly it shows is that, so it contains the summary of zeros and 1, that is 18 in count, like changes happening from server to device or device to server. So here we take an example, like if there is a mail is sent from the device to the server, the changes in this particular section will show as one change. So in this example, we can see that there is a D2S mail 1A. So that is number of mails created on the device sent to the server. So D2S mail 1A it will show that from device to server there was one mail addition which was done from device side. Similarly, we have the mail add, mail update, mail delete. Then we have similar for contact add, update and delete. Similar for calendar and for the journal. Move to the next slide, please. The NTS errors files contains the errors that IBM travelers encountered. So these are the just severe level error messages. Here on the screen you can see the error message, that is the server not responding, server may be down. So in this transaction it is seen that the prime sync, that is PS thread, was initiated and there was an exception thrown. The failing scenario is that the primary mail server is down. Further to this, user may check whether the mail server is accessible and reachable, and traveler server is able to trace the mail server. Move on to the next slide, please. The NTS activity log. The NTS activity log contains the information about the NTS errors, NTS audit, NTS usage information, plus anything else that IBM traveler logs. So this NTS activity log in the traveler contains everything that would be would be starting from NTS star.log. So it will show the audit, usage, activity. So here in the section you can see that it shows the tracing of the user and server. So in the basic layout of the log message, you can see like what exactly it has captured. So in the timestamp, the local date and time to millisecond precision is captured, and there is a level. It shows the severe level, warning, info, fine, finer, finest, fine. So by depending on the level, like what level we have set for a particular user. It is the finest level we are set, or it is a fine level set for a particular user for troubleshooting. So we can see whether the level is set to finest or fine from here. So there is a thread identifier. It shows the thread name with the optional correlator in the brackets. There is a user ID which in the canonical name format. The source ID is there. The source ID is the class or method and the line number that originates the message log, followed by the message text. There can be any message text. So here in the example, it is seen that there is a fine level logging for the user, and there is a device sync in process to the Apple device. So move on to the next slide, please. The NTS audit file. The NTS audit file contains changes to the system, such as settings change, or it is server document, notes.in, and so on. So if you do any changes on the traveler server, so all the things get captured into this particular file. It also captures the tail traveler commands. So whatever commands if you issue on the traveler server, like tail traveler version, so whatever commands you issue, it will capture those commands as well in this particular audit file. So on this screen we can see that there is a value changes done in the system. More on, we can see that there is a tail command fired on the system. There are configuration changes as well, which shows the old value and the new value, that is like when configuration happened. So like all the NTS blocks have the name in the format NTS star with the year, month, date and the time format. So where the time will correspond to the date and time that log file was created. So all these files are very useful, and it contains the header section that describes the format of the message applicable to the file. Like as we talk about the NTS errors, audit, the NTS usage. So all these log files are helpful for the initial level troubleshooting. Shikant Dahide will take over from me.
Thanks Jayesh, and hello everyone. So we will have a look at some sample scenarios and how different logs can be reviewed to understand what is causing the issue and further take appropriate action in resolving same. So we will demonstrate some common scenarios which generally customers report to IBM support, and similar troubleshooting mechanism techniques can be applied for troubleshooting other issues as well. So let's have a look at a sample case. It might happen that users start complaining that emails are not synchronizing to device, or if they are synchronizing, the performance is very slow. So as a first step in troubleshooting this kind of issue, always issue a tell traveler status command and a system dump command. So for this particular case, we see that the traveler status is red, and the reason it is showing that there are many sync failures reported because the server is too busy and it is rejecting the sync request with the error code 503. 503 error code is written by the server when it is running at full capacity and cannot accommodate any new request. When the reason for the status is clear, check the CPU and memory table in the system dump. So generally the CPU and memory table would give a fair idea about when the performance issue started on the server. Moving on to the next slide. System dump contains the statistics for the last 24 hours. So as we can see in the CPU and memory table on the screen, the number of errors and the DB connections suddenly spiked after 6 p.m. Traveler task will keep doing regressive read and write operations on the NTS DB, where it stores information about all devices and user profiles. So these active connections are called the DB connections. So if for any reason the DB connection goes high, it is going to increase the errors, CPU and the memory. So as a next step, we will try to have a look in the NTS activity to understand more on this. Moving on to the next slide. Now for the affected time, if we check the NTS activity, there would be many errors for the prime sync and the device sync threads. As we can see, the requests are getting rejected because traveler is in constrained state because of the system resources. And if you can see the transaction, the sample transaction on the screen, it also prints at the end of the transaction that the traveler is in constrained state. The reason in this scenario is that the active database connections have crossed the default maximum threshold value of 280. So we will understand more on what is exactly this constraint state in the coming slide. Moving on to the next slide. As we saw in the NTS activity, traveler is rejecting the prime sync and device sync thread because it is in constraint state. The reason being the DB connections have gone high. Now the DB connections can basically increase because of two reasons. Primarily, if the NTS DB is not indexed or is not in a good health, that is causing slow response in the read-write operations that can cause the DB connections to increase. Secondly, if the hard disk or the storage on which the NTS DB resides, if that storage is performing slow, that is also going to increase the DB connections. So basically, Traveler keeps monitoring its own statistics and thresholds for various configurations and performance monitors. So at any given point of time, if Traveler identifies that it has crossed the defined threshold for any of the performance monitor, it will term itself as running at full capacity, which is called as constraint state. And once the Traveler puts itself in the constraint state, it will stop accepting any new transactions from either the server or from the users. So the new connections that come to the server when the Traveler goes in constraint state, they are rejected with 503 error. However, the existing connections that were already accepted by the server, they would still be serviced. So now for this particular example, to resolve this particular Traveler performance issue, the admin has to resolve the high DB connection issue. So either a maintenance can be run on the NTSDB, or maybe the disk level maintenance can be done to improve the disk performance. And once the DB connections don't exceed the defined threshold, the performance issue should be resolved. Moving on to the next slide. We will have a look at another scenario where traveler status is red, however there is no issue faced by any user. So sometimes this kind of issue might bother the administrator when the server keeps on showing in the red status, but there is no complaint from any user and everything seems to be working fine. So as we see the status output here, we can see that the status of the server is red. The reason being 89 errors were reported by the traveler in the last interval. However, if you notice, they are not 503 errors. So this kind of red status because of unknown errors can be tricky at times, and for understanding more on these errors, you will have to take a close look at the NTS error logs to understand same. For red status, when the error code is not dumped in the traveler status, the system dump log will not help in understanding the cause of the issue. Moving on to the next slide. In this case, in such type of cases, always check the NTS errors log, and for the affected time when the status shows red, see what all errors can be seen in the server. So just basically try to narrow down if the errors are specific to certain type of request only, or maybe just specific to some users. I mean, if only a particular user is encountering a lot of errors, or if certain type of common event is generating some error on the traveler. So for an example, as shown on the screen, we see that there are multiple active sync errors displayed for just one user. So now if the particular user or device is continuously trying to sync and generate error, that will cause the traveler status to go red because it will exceed the default threshold of maximum errors. So to suppress this particular red status scenario, you have to simply fix these errors which are occurring for either a user or a device. So there can be multiple reasons for above error. Basically, if the user device is not supported, for example, if an Android device is configured via ActiveSync and not the traveler application, that can cause errors with every mail when it streams to the device. Then there may be some corruption in the user mail database that is causing the emails to report error while synchronization. If in cases where above two reasons are not the cause for this particular error, then it can be some kind of traveler bug in syncing certain type of MIME email or maybe attachment. So for that, maybe you can just collect all the information and contact the IBM support. Moving on to the next slide. We will have a look at another case where intermittently traveler server stops synchronizing email to user. However, it auto recovers without any administrator intervention. So basically, this kind of issues are reported from many customers where sometimes during the off shift, maybe the user stopped receiving emails, and while there was nobody in the office, automatically the server recovered by itself. So maybe you want to know like why this kind of issue happened on the server. So for troubleshooting this kind of issue, always take a system dump log when the issue had occurred on the server. So basically, system dump collects all the actual statistics from the traveler when the issue had happened. So in the system dump, check if the status of the traveler server is yellow or red, and check if the reason is printed why the status is not green. As we can see in this example, there are multiple threads for some users which are running since long time, and response time for opening mail database on a particular server is above the acceptable threshold. So these two reasons in together are causing server to intermittently go in a hung state, and which is why the users stop receiving emails on the device. Moving on to the next slide. Check the system dump statistics for the server which has slow response time as shown in the status section. As we can see in this example, server 1 is taking a longer time in completing the request when traveler is trying to access it. Ideally, for a good connection, all requests between the traveler and the mail server should be completed within the time frame of 2 seconds. However, in the system dump, we can see that many requests for this particular server have crossed the time duration of 5 seconds. So if if there is a connectivity issue, that will cause the threads to be held up for a longer time, and that would impact the traveler performance. Moving on to the next slide. A question may come in the mind that if the traveler is going in a hung state, how will the system dump command work? So yes, it happens at many times that traveler task goes unresponsive, and even if you try to run the system dump command, it is not going to yield any result or the output. So in that case, always check the NTS error log for that given point of time, and check the detailed information of all the errors transactions that are reported for that time. For example, during the time of issue, if we check the NTS error log for this particular case, we can see error where the transaction fails to the remote mail server with the error retrieving data from the server. The complete stack what is printed in NTS errors is available on the screen for your reference. So to fix this particular intermittent traveler hang issue, you can just try to fix the connectivity or the response issue with the affected mail server, and once that is fixed, the traveler performance crunch issue should also be fixed. Moving on to the next slide. Manish will take over from me now. Over to you, Manish.
Thanks, Ahire. Hello everyone. Moving forward in upcoming slides, we are going to cover what is required on Domino and Traveler part to make iOS device work, and what exactly has changed with iOS 9 device for it causing to stop syncing emails. Also, what will impact on old Android device and existing user by making the changes to Domino and Traveler. We'll be looking on what needs to be done so that we can make Verse app work for Apple device, and is it mandatory to use SSL. For an iOS device to work, your Traveler server needs to be upgraded to 9017 or higher, and apart from that, also your Domino server needs to be upgraded to 901 FP3, IF2 or later release. Moving on to the next slide. For an iOS device to work on your Traveler, customer may have a query that Traveler requirement says that I have a Domino 8.5.3 and still I can upgrade the Traveler server to 9017 or later release. Reason why you need to upgrade your Domino server to 901 FP3 or later release is because in iOS 9 they have introduced a new protocol called App Transport Security, which uses TLS 1.2 methodology to communicate to the Traveler server. Hence, if your server is not capable to communicate with TLS 1.2, then iOS 9 device will not sync mail. After you have upgraded your Traveler server to 9017, it will start supporting to synchronize mail with iOS 9 device. Moving on to the next slide. After upgradation of your server, there are some additional parameters which you can add in the notes.ini, which are optional. One is disable _ SSL v3. By updating this parameter, it will make the server secure from Poodle attack, and the other parameter is SSL cipher spec. Moving on to the next slide. If you are having a HA setup in your organization for Traveler, and if load balancer, reverse proxy or IP sprayer is in front of your Traveler, then they should be able to communicate with TLS 1.2, else connection between the device or Traveler will fail, which could cause sync issue. In case of your HA servers communicating with each other with HTTP, then there is no changes required, but if it's HTTPS, then it has to be ensured that cipher between the Traveler and load balancer matches. Moving on to the next slide. We have seen customer reporting that I have upgraded the server to the Domino latest release as recommended, but getting errors in console such as connection failed with server certificate and our server has a self-signed certificate. Now if you are having a self-signed certificate with MD5 algorithm and you have just upgraded your Traveler server to 9017 and Domino to 901 FP3 IF2 or later release and not updated the SSL certificate, then you get these kinds of error on your console. Apart from this, iOS device user will not be able to sync their mails, and Android users which are having lesser than 4.4 version will also not be able to sync mails. Hence, to fix this, you need to update your SSL certificate with SHA-2 or at least SHA-1 for an iOS 9 and Android device to work. Moving on to the next slide. For an older Android device to communicate with Traveler server, the parameter SSL_disable_TLS should not be set, since older Android are not capable of communicating over TLS 1.2. So make sure that this parameter is not updated to avoid older Android device sync failure to happen. Also, you would have noticed that on your server console with error TLS/SSL, error with rejected protocol version. This error is thrown because device is trying to connect with a protocol which is actually not supported by the server. And to suppress this, you need to update the parameter SSL_logging_disable equal to 1 so that above error is not thrown. Moving on to the next slide. There are questions by many customers that I am unable to sync mail on iOS device using IBM Verse app. This is because you do not have trusted third-party SSL certificate. For an IBM Verse to work on iOS device, you need to have a trusted certificate. If your server is having a self-signed certificate, then IBM Verse will not work. Though you need to have an SHA-1 certificate for an iOS 9 device to work with an active sync. Also, we have seen customer with query. Currently, we do not have SSL and need to enable that on the Traveler server. Hence, if we update the Traveler server with the SSL, how exactly will it be impacting my existing users? If the users are using Android device and you have updated from HTTP to HTTPS, then they will not be able to sync mail on the device as the URL has been updated to HTTPS. Hence, they need to reconfigure the device with HTTPS for an active sync to happen, for the mail synchronization to happen. But for an iPhone device which has an iOS 8 or later release, they have an option to toggle from disable to enable SSL, which we do not have in the Android device, resulting to reconfigure their device. Moving on to the next slide. Once you have upgraded your Traveler server to 853 or 901 IF8 to 9013, you will see the below results while accessing Traveler home page for configuring your Android and iPhone device. Your user will have an option to configure using IBM Verse app or as a profile in iOS device. Moving on to the next slide. These are the various reference links where you could refer in detail with what we have discussed. Now I will hand over the call to Narendra. Over to you, Narendra.
Thank you, Krish, and thank you, Jayesh and Srikanth, for a very informative session. We will now be opening up the lines for question and answer, so please feel free to ask questions on